AP Physics, page 313, day 10, problem number 40. Now this is kind of a conservation of energy problem. In the best case scenario, if there's no friction, the amount of energy you start with mechanically is the amount you end with at the end mechanically. But if there's friction, which there is in this case, there's going to be a transfer of mechanical energy into heat energy, which we'll find this way. The car starts at the top of a hill, and it's going to have a loss of GPE. There's going to be a delta GPE. The delta GPE will be the mass of the car times G times its delta H. I'm going to call this delta H. Delta H is going to be 100. So you know the mass of the car, and if you just run a round off, well, that's 1,000. G is 9.8. You can round off that to 10. And delta H is 100. So basically you can have 1,000 times 10 times 100, which is, what is that? That's a million. A million joules of GPE. You can write that down. At the bottom or at the end, wherever that spot is, 100 meters lower vertically, it might have been an angled slope, but you've had a vertical displacement of 100 meters. You find your final kinetic energy. Assuming it did start at rest. The car started at rest, so it's delta KE. In the best case scenario, it would have been a loss in GPE, but it wasn't, more than likely. You're gaining KE is just simply 1/2, it says 1/2, times the mass of the car, 1,000, times delta V squared. Well, that's 20 squared, so 20 squared. So 20 squared is 400. Half of 400 is 200 times the mass of the car. So what is that? 200,000 joules. So it lost 800,000 joules of mechanical energy because it started with 1,000,000 joules and ended up with 200,000 joules. Plug those numbers in to double check because I was doing a lot in my head there. But mechanical energy is not destroyed. It's transferred into heat. But mechanical energy, which is typically potential of some sort, GPE and kinetic, can be transferred easily into heat energy, as in this case.